I'd like to describe a little bit the Lego Part Warehouse. Lego Part Warehouse is a fictitious warehouse that we've created to help teach concepts in test design, agile requirements, and pragmatic analysis. Lego Parts Warehouse Manager is a piece of software that manages the Lego Parts Warehouse. I'm sure you all remember Legos. Legos are basically building blocks. They're a wonderful tool to construct all sorts of models, and they're used all the way from very young children to seniors and everyone in between. And today there's a huge community of people that use Legos to build robots. There are other communities that build it to build realistic models and artwork. And certainly it's become quite an industry. Legos themselves are from Denmark and are available now in stores and shops all over the place, including a chain called the Lego Store. So you can imagine the Legos since the 1950s have been manufacturing parts. Over the years, they've come up with thousands and thousands of parts. Today, people who are collectors of Legos may choose to get individual parts from a couple of sources of used Lego parts. Some parts are very hard to find, they're very expensive, and some parts are quite common. It's interesting to note that there's over 16,000 parts that people look at in the world of Lego. So what we've done is we've created this sort of fictitious Lego part warehouse to help manage them. And you can imagine that people buy Lego parts and place orders for Lego parts, and people receive Lego parts. So the software that controls the Lego parts warehouse, we hope, is very simple and very similar to software that might be used to manage inventories, warehouses, parts, distribution centers, etc. In either case, the warehouse itself, fictitious as it is, still has purpose, right? So the purpose of the Lego Part Warehouse Manager is it's a software system used to coordinate storage and retrieval of Lego components. I want to put a Lego component here. I want to retrieve it from there. So we want to basically store and retrieve Lego components. The Lego Parts Warehouse Manager allows customers a wide variety of Lego components for use in constructing Lego models. So we want variety of components, not just building blocks, but all the things, the windows, the wheels, all the stuff that Legos have had over the years. And that includes little figurines and stuff like that. The Lego Parts Warehouse Manager is operated by independent resellers of used Lego components. This is not affiliated in any way with the official Lego group. So this is just outside of that. It's used parts by independent resellers. If you want a nice sort of look at what is a Lego, there's a beautiful little article in Wikipedia that sort of talks about them, and it's got a beautiful description. I'd just love to quote this directly. Lego consists of colorful interlocking plastic bricks accompanying an array of gears, figurines called minifigures, and various other parts. Lego pieces can be assembled and constructed in many ways to construct objects, including vehicles, buildings, and working robots. Anything constructed can then be taken apart and the pieces used to make other objects. So this is from the Wikipedia article, Lego. So it's pretty neat that people actually can build another model later and keep going and going and going. So that's Lego components. For the Lego Parts Warehouse Manager, the system that we've envisaged here, there's a lot of different processes. So I put together this little process diagram to sort of map out the relationship between them. Now, the process is just basically an individual chunk of software that does something or is responsible for something, and that we can sort of tell if it's broken or not. So we can tell if it's running or broken or working or not. So we can say, okay, this component is in this state of operation. So if you start look at this picture, start at the center going out. The middle of it is a component called the Inventory Manager. Now, the Inventory Manager is invoked by a process which puts things away and a process which retrieves things. And then there's, so what we call the retrieving is called picking. That's a term used a lot in the warehouse business. And the putting away is called putting away. So putting away comes from a receiving process. So that's a process that when we receive Legos to put in the warehouse, the receiving process uses the put away process, which uses the inventory manager. Now, when we're sending out Legos, we're ultimately shipping them. So basically the inventory manager sends the Legos through the picking process to the shipping process. So going out and coming in. The inventory manager also deals with product information. So somehow a Lego set might have many parts and components in it. So there's product management. And then the product manager breaks that down into parts. So the inventory manager might say, okay, well, here's a product like a Starship, a Lego set. What are the parts? And there might be dozens and dozens and dozens of parts in one product. And the part manager has a couple of things that it works on. One is a location controller, where the part manager can control where in the warehouse it is. That we put them in what are called bins. So what bin is this part in? Where is it? And the location controller can also be used to move the bin around. And then there's a reorder process when the part manager somehow tells that we need new inventory of a certain component. They have a reorder process that they invoke. So the reorder process would basically then order some Legos from outside, and they would come back through the receiving process to fulfill the order. Also, there's a lot of data management in warehouse systems. And so the inventory manager communicates with and deals with data management software, which also is therefore used for report generation. So these are the fundamental components here, the process elements that are inside of the warehouse manager. So you can imagine now when a development team is asked to implement a new feature, they'll be modifying these components, or they might be adding to or taking away these components, or they might be changing the relationships between the components. So the block diagram helps to get a feel for what are the software components and how do they relate to each other. The Lego Parts Warehouse Management software, like almost every software system, has many different types of users. And so when we're looking at product development and looking at requirements, we might want to know who is the user and what do they want to do. So the users of the Lego Warehouse Manager could include operators, inventory managers, sysadmins, auditors, warehouse pickers, and consumers. So this is the types of users that we imagine. Now, the consumer would be someone who's buying something from the Lego warehouse. The warehouse picker might be the employee or the process, right, that grabs the Legos. Auditors make sure that the inventory records match reality. Sysadmins do things like add new users and make sure, configure, reboot, backup, and restore the system. Inventory managers, process that basically keeps track of what is inventory, what are parts, part number allocations, barcode allocations, things like that. And the operator is just the employee who's using the system internally at the Lego Warehouse Company. Now, just to put it in terms here, the operator, end user of the warehouse management software. Inventory manager, responsible for defining and acquiring products and parts. Sysadmin, responsible for maintaining the system, authorizing users. Auditor, one who validates reports against actuals. Warehouse picker, an entity, and I say entity because it could be a robot or a person. It's an entity who takes parts from bins in picking. So this is interesting because there's a bin and a track. So if you can look at a model here, we have a whole bunch of bins with Legos in them, and they're on tracks and they move around from one track to another track. Then we have a consumer, that person who wants to buy the parts. Now, when I'm looking at requirement management systems, one thing I look at is who are the user. I also look at what are the objects that we're manipulating. And so the Lego Parts Warehouse Manager manipulates 6 different types of objects, possibly more, but this is the fundamental stuff. So they manage orders, products, parts, what are called pick lists, bins, and tracks. So just to give you a little bit of definition of those. An order is placed by a consumer to acquire products. So it's just like a purchase order. I am buying something, it is an order. Product is a collection of parts. A part is a component which has a unique size and several other defined attributes. Every single part has a size, but they have different types of attributes. For example, one type of Lego might be opaque or transparent. One might be rimmed or not rimmed. So there's all sorts of terms that are attributes that vary, but every single part has a size. Pick list is a list of parts to be gathered from the picking area to fulfill an order. So if the customer made an order, the pick list is to fulfill the order. The bins is the container with a specific size, which stores a collection of identical parts. So every bin has one collection of identical parts. One collection of identical parts in a bin. Now, depending on how big the bin is and at the size of the parts, there might be a different number maximum there. But the bins by themselves have one part per bin, not 2 or 3 different types of parts in a bin. The tracks are what the bins are on. Think of this as basically like tracks in a railroad yard or something, a stockyard. So the bin is on a track and it moves around. The positions that it moves around are called slots. So you have a track with slots, and there's several tracks with slots. Track 0 is the one that's closest to the picker, and track N, whatever N is far away. So 0 is close to the picker. So when we're picking something, we have to move the bin to get to track 0 from wherever it is. Now, if you look at the types of stories we have, types of requirements we have related to the Lego Parts Warehouse Manager system, there's all sorts of them. We can have stories that authenticate things, so adding users, removing users, changing attributes of user, maybe changing their name, address, password, suspending a user, renewing a user, and there might be all sorts of reasons to suspend someone. Maybe someone's trying to hack their account, or maybe they owe us money. Change user privileges, so what is the user allowed to do or not? Lock out a user, query a list of users, query user attributes, query user status, query the system usage, and deprecate users. So these are all things we can do. We say deprecate is make a username so that it can never be used again. So it's deprecated, it's gone forever. There's a bunch of system administration stories. We have a full backup, full restore, data integrity checks, integrity check of the system, upgrade the system, downgrade the system, reset a system. Those are things the sysadmin might do. Install and remove patches, monitor dynamic characteristics like CPU, memory, network, and storage availability. There's auditor stories. We can audit, generate inventory reports, generate inventory change reports. So what's changed from yesterday to today? Generate transaction summary reports. What summaries have we had? Generate user summary reports. What have users been doing? Generate user change summary report. What is different from the previous time users did things? Generate part consumption charts. How are our parts moving? We have operation stories. Get orders from customers, fulfill order from customer, get order change request from customer, fulfill change request from customer, cancel order, process order. Get a part, now there's inventory management. Get a part from inventory, return a part from inventory, add a part type, change a part type, remove a part type, add a part attribute to a part that's already there. Assign a part to a bin, change what part is it, what bin, remove a part, bin assignment. And then we can add SKUs, which are the codes used for barcodes. We can create a SKU for a part, modify a SKU for a part, or deprecate a SKU so it's never going to be used again for a part. It's also inventory management, also sees us doing things like taking the contents of a bin and splitting it into 2 bins, or combining the contents of multiple bins into 1 bin, remove part warehouse bin assignments, add a bin, remove a bin, or query the bin status. So there's all sorts of stuff we can do manipulating bins. We can also, of course, move a bin, query where it is, so query the position of the bin, remove the part warehouse bin assignment, add a bin, remove a bin, and query the bin status. For pick lists, well, we can create, change, or delete a pick list, assign a pick list to an employee, reassign it to someone else, and complete the picking of it. So that's a sort of set of user stories. What are sort of requirements for the system? We also have some technology algorithms built into the system. If you're interested in the technology of it, we use an LRU algorithm, least recently used algorithm for optimizing the picking. So whenever we want to get a part and we have to pick it, the first thing is to move the bin to the picking area. So to move it wherever it is to track 0. And unfortunately, sometimes the bin is not in track 0. It might be in track 7. And so what we do is we use an algorithm called an LRU, least recently used algorithm. So let's say you're on track 4 and the bin we want is on track 4. We need to get it to track 0. So the first thing we do is we look at track 3. We find the least recently used bin on track 3. Then we swap our bin for the least recently used one on track 3. Then we look on track 2 for the least recently used one on track 2, swap with that. Then on track 1, swap with that. Then on track 0, swap with that. And we end up with the more frequently used bins in the lower track numbers and the rarely used ones further away. And this sort of caching is used to sort of try to optimize the speed of picking at the warehouse. That algorithm is also used, by the way, in virtual memory management, in computer system architecture, if you're interested. So if you're interested, this is the bin caching algorithm we try to use. Now I want to walk you through an example story that's sort of like formally put together, I guess, using methods that you might see on an agile software development project. So we might see the Lego Parts Warehouse Manager story, create a pick list. So this is the create a pick list story. It's written in what I call the Cohen style, named for Mike Cohen and his book, User Stories Applied. So it starts like this. As a Lego Parts Warehouse operator, I would like to create a pick list from a customer order so that a warehouse picker will be able to fulfill the specific order for the customer. Who is the user? What do they want to do and why? So who is the user? It's a part warehouse operator. What do they want to do? They want to create a pick list from a customer order. Why? So that the order can be fulfilled. So we always have a who, what, why. So that's the user story, and that's how it would be described. Now, when we have a user story, we like to collect, associate with it, what people call acceptance tests. The acceptance tests for the create a pick story is, after interviewing, and by the way, I did interview someone who does parts management for, not for Legos, but for inventory in auto parts industry in Canada. So I do have some knowledge of this, and I did interview someone about this. So for the create pick list story, first thing we have, and this is just a list of them, and I'll go through more details. The first one is a normal flow, an example of a normal flow. A normal flow is a typical example that's successful. So a normal flow might be, I have a valid operator, and the operator has a valid list of several existing products which exist in inventory. So that's one normal flow. An alternate flow might be a valid operator with a list, but with only one product in the list. Or another alternate flow might be a valid operator, and they have a list of existing products, but there's duplicates. So they might say, well, I want 10 windows, and I want 15 wheels, and I want 10 windows. So there's a duplicate on the window one. That, of course, we want to give them 20 windows when they have that, but how do you manage the duplicates? And then there's error flows. What if I have a valid operator, but they order one product that is not in inventory, that does not exist? Or another error flow. They have a valid operator, and they have 2 products in the order that don't exist. So if there's 2 that don't exist, or what if they have an order, an error flow, and all the products do not exist? Or what if they have an invalid operator, someone who doesn't have an account or doesn't have the privilege to do this? And what if we have a suspended operator? If you remember before, I told you the suspended operators, one of the states we have there. We have alternate flows. Maybe you have a valid operator and you want to take a single product, but that product internally is spread across multiple bins. So if they want to have a bunch of stuff, but it's in multiple bins, how do we do it? What if there's an error flow and we have a single product with insufficient quantities? So there's not enough of them, insufficient quantities. Or an alternate flow, multiple products fulfilled from multiple bins. So 2 or more products from 2 or more bins each. An error flow, multiple product requests with insufficient quantity in multiple bins. So you have not enough stuff in multiple bins. For reference, I've just put together a few examples with Lego parts. So there's some little picture of the part here, official name of the part, and actually part numbers for the part. So we got, for example, if you look at this 3001, that's a regular brick, it seems like there. And we've got 3001 OLDB, and that seems to be one with a little reference point in the middle. They all have some sort of differences here. On the right, I've just put what bin they're in. So for the purpose of this example, there's also a bunch of types of windows, again with the part number, and again with the bin assignments, and a whole bunch of different types of wheels. I like to point out that there's wagon wheels here and car wheels and all sorts of wheels, and what bins they're in. So different types of bins. Different types of wheels and different bins. Here, I want to share with you, and I'm not going to read through all of them in detail, but I'm going to share with you the acceptance tests for the create pick list, but described using a method called Gherkin, which is a language which is used by tools like Cucumber to help automate acceptance tests. And Gherkin becomes a very, very nice way to collaborate and communicate across team members, and also to drive automated acceptance testing as part of your Agile project. So if you look at the text of this is in a file with a .feature extension, but you start off with the features, the story, create pick list. So there's the statement of the story as we had earlier. As a Lego part warehouse operator, I would like to create a pick list from a customer order so that a warehouse picker will be able to fulfill that order for the customer. We have a scenario. So each acceptance test is called a scenario. So this is just the text I used here. Pick several valid products as a normal flow. That's my notation. So Gherkin uses the triad given, when, then to describe the acceptance criteria. If you just read it naturally in natural English, you'll see exactly what it's trying to do. So given user Fizbin is logged in as the operator and the inventory has been initialized, when the following products are requested, i.e. quantity 100 of 3001 old, a quantity of 20 of 645A, a quantity of 2 of BB19, then the following pick list should be returned. Bin 1900, take 100 units of part 3001 old. Bin 2011, take 20 units of part 645A. Bin 1892, take 2 units of part BB19. Given, when, then. Given the user Fizbin is logged in and the inventory is in some sort of controlled initial state, then there's a list of what's requested and the result, the expected outcome, the list of what we expect at the end. So this is just one example of an acceptance test. There's a couple more here. What if we want to try the alternate flow of one valid product? Well, okay, I take the pretty similar to the previous one. Given user Fizbin is logged in as the operator, when the quantity 25 of part 645 is requested, then the following pick list is returned: a bin 2010, quantity 25, part 645. Another one, picking several products, including duplicates. So you'll have, given user Fizbin is logged in as an operator and the inventory is initialized, when the following products are requested. And so you see he's got 13001 old, 20 645A, 123 3001 old, 2 BB19s, and the output is, well, the following pick list is returned. So bin 1900, 223, because that's where 3001 old was. So you see that we've added the 200 and the 123. Bin 2011, 20 645A, and bin 1892 to BB19. So you see you'll have to do only 3 picks to get these 4 lines done. And we've gone through several different examples. You can walk through them yourself at your grace. Take your time. Just to give you an example. Here's an example of one where the product is fulfilled from multiple bins. So imagine this, a single product fulfilled from multiple bins. So given user Fizbin is logged in as an operator and the inventory count is defined to be, and I have a list of bin 3000, 3001, 2, 3, 4, 5. I have what part and what count is in those bins. So that's like the precondition. When the quantity of 225 of product 3001 old is requested, then what's going to happen? And you'll get the result would be, well, take 200 from bin 3000 and take 25 from bin 3001. So you see that we have they split it because there's not one bin that has more than 200. So to get an order of 225, you take some from bin 3000 and some from 3001. And it, we get more and more of these cases. We have the fulfillment from multiple bins case here. If you read through it, you'll see that we say at the beginning, here's what the bins have in them. Here's what our order is. Here's what our output is. And in this case, we would have the product fulfilled from multiple bins. So even though we've got 3 products, it's going to be looking at 1, 2, 3, 4, 5 bins because 3001 old and BB19 have to go to 2 bins each to get the products out of them. So I'm not going to go through any more of those stories, just to let you know we have a whole bunch of them in there. And in Agile teams, when they're doing development with Gherkin, this would be a way that people can express the acceptance test. And generally speaking, Gherkin is something that can be used by both non-technical people and technical people on project teams. So it's sort of nice language to use to communicate what are the acceptance criterion for a story. When Agile teams undertake to implement a feature, they would generally have a planning meeting at the beginning of their sprint. And in that planning meeting, they know the story already, but they want to figure out what is the actual technical work we have to do during the sprint. What is the real technical work? And they would look at usually a discussion with the technical people in the team, and the whole team should be actively involved in the discussion to figure out what's going to change. I've just illustrated here an example. This is a diagram of the changes that are anticipated in implementing the story I just shared with you. So imagine there's this group of people, programmers, testers, they all get together, they take a look at the story, they discuss technically how it's going to be programmed, and they can look at this block diagram, the one we had from the design, and they can look and sort of some blocks will not be touched at all. Some blocks will have minor code changes. Some will have significant code changes. So if you take a look at this, the shipping process, inventory manager, and product manager will have minor code changes. The picking process and the part manager will have significant code changes. So this helps us when we're trying to identify technical risks. The more significant code changes in it, the more likely it is that people may have accidentally injected bugs into the software. And when we're doing testing of a story, for me, it's very important to consider cross-feature interference. So what other features use the processes that are having significant code changes? So if you look here, the part manager, well, I may want to identify some exploratory testing tasks related to the part manager, even if it's not the pick list story. So I want to make sure I didn't break something else that uses the part manager, or I want to check something else that uses the picking process. So this diagram, block diagram of what's being changed, indicating maybe with color codes or some other notation where there's going to be significant or minor code changes, helps the team to decide what testing might be relevant based on the real technical work that's going on by the team. So this is just an example here of the testing tasks identified in a planning meeting at the beginning of the sprint after the discussion. So we've looked at the block diagram, we've discussed the story and the acceptance tests, we know the acceptance test, we know the story. Here's the testing tasks. So one example here. We're going to do some paired brainstorming of unit testing ideas. We're going to review static analysis results related to complexity and security of the code changes. We're going to create feature files for the acceptance tests we looked at. We're going to integrate the feature files into our integration servers so they can be automated. We're going to create step definitions, which is the hook between the the Gherkin script and the automated testing, so called step definitions. That's a testing activity that's very often done by the programmer who's creating the feature. We're going to actually run the acceptance tests. We're going to put hooks in the code, enable us to use scripting. We're going to confirm we can make pick lists with Pareto combinations. That's the most common picking. We're going to confirm pick lists can be created with pairwise complete set of combinations. So we're going to look at all the whole bunch of variety of part combinations and use pairwise analysis to come up with sets to pick. That'll help us find outlier bugs. We're going to confirm pick lists can be created with variations using domain analysis for the number, order, quantities, and product types. This will help us, for example, identify boundary bugs. Confirm pick lists can be created with variations using domain analysis for the number of items in order, order quantities, product types, and the number of associated bins and variations in bin counts. Again, we're doing domain analysis to come up with testing for that. Confirm pick lists can be created with variations using boundary analysis for number of items, order quantities, and product types. So these are the type of things that we've discussed. We said we want to beat this up with our testing. Some other things we might want to do. What if wrong parts are in bins for target parts? So we'll do testing to see what happens if the wrong parts are in the wrong bin. What if the system has a power failure in the middle of a transaction? So we want to do some testing like that, simulate those conditions, see what happens. We want to also make sure, this is the cross-feature interference, can an operator add a new part to the system after the change? Can an operator add inventory to existing parts after the change? Can the auditor generate inventory reports after the change? That's looking for cross-feature interference. We want to study also some non-functional elements of the system. We want to study the time performance as we vary the size of an order between 1 and 10,000 individual items. We want to study user experience by having novice users try this, doing some paired exploratory testing. We might want to also study the user experience with experienced users in a controlled environment. We want to exercise pick list story while new items are being added to inventory. So doing multiple things at the same time. Can we create pick lists as inventory is being changed? What if the item being requested in the pick is being deprecated during the create pick transaction? So you have two things going on at the same time. We want to make sure we can do an end-to-end test paired with the programmer to make sure we go through all the right process steps at the right time for a generic pick order, pick list generation order. We also want to try see how the system behaves if the data is corrupted, and we're going to use fuzzing for that. We're going to walk through the code paired with the developer in the sandbox before the code is checked in. And that's it. That's the type of stuff we see. It's an imperfect world. We can't test everything. The risks that we want to test should be based on many things. However, not just the story and the acceptance test. I like to say, yes, we have to start with the story and the acceptance tests, but there's also testing based on what's really changing in the software. Plus, in general, there's also the environment the software lives in. So that would be it. Thank you very much.